On est aussi sur YouTube.
Yes. Voilà, moi, c'est comme si j'étais au bureau.
En effet.
Sauf que peut-être qu'il neige à Paris, j'en sais rien.
Ah non, au Pont, il neige en tout cas, ouais.
Ouais. Je vais rester bloqué en été. Ah, cher.
Cuando ya había saldado.
Tu veux essayer juste de le partager pour voir si ça fonctionne?
Ouais, j'essayais de voir comment je pouvais faire.
En bas au milieu, je sais pas si tu vois.
Ouais, mais je voulais partager les bons écrans. Comme moi, j'ai l'habitude de Teams. Alors, lequel des deux.
Hello everyone, we just wait for a few minutes to set up. Ah,
Au début. Ça a l'air pas mal.
bon, très bien. Je propose qu'on attende 2-3 minutes encore et puis après on peut démarrer.
Ok.
So I think maybe we can start. That's okay with you, Kim?
Yes.
Welcome everyone for this second edition of the conference cycle of the Executive Master of Digital Twins for Infrastructures and Cities. So today we have the pleasure of having Guillaume Villemain, who's the CTO of Altametris. So I think you represent Altametris, but just very briefly, it's a subsidiary of SNCF Réseau, and its activities is related to the inspection and collection of data on the railway network using various techniques. So I think you will probably present the different techniques that you use and process this data using algorithms and other tools and software. So Guillaume has a PhD in signal and image processing, and he's been focusing on designing railway diagnostic system for predictive maintenance. And just to finish, Altametris is also a partner of the consortium which led to this project and the creation of this executive master program. And I think last year we were involved in some capstone projects as well. So it's a real pleasure to have you here with us today, and I give you the floor for maybe like 45 minutes, and then we'll have some questions at the end. So thank you again.
Thank you, Jeremy. It's a pleasure for me to be here. Also, so I named the presentation 3D Digital Twins in Railways, Transforming Data into Actionable Insights, because that's what we're doing at Altametris, part of, and I will say some word about Altametris, who we are, what we do. You summed up Jeremy, that, but I'll dig a little deeper. And on that subject, you said we are a subsidiary of SNCF Réseau. That's true. SNCF Réseau, you know, SNCF Réseau, if you're French, maybe. If you're from another country, maybe not. So SNCF Réseau is the asset manager for railways in France. Railway in France is it's 27,000 kilometers of lines, in which there are like 3,000 high speed. A lot of station and a lot of traffic, a lot of people working in that company, and Altametris in that I would say ecosystem is a subsidiary founded in 2017. We are about like 50 people, and we aim to bringing performance in asset management using data, and especially for railway infrastructures. So that being said, we have 4 key services and data expertise in railway. So we deliver software, SaaS software for processing data, visualization at large scale, and we'll dig deeper into that large scale problem afterwards. We have some solution for data acquisition, data collection, so we can do data collection and we can teach people and give them like drones and stuff, so they can do that more with more agility. We have a dedicated part of the company which is dedicated to topography and inspection support for railway industries. So it's like professional services using the software I just presented. And then we have the R&D expertise consulting part that covers the two scopes I just mentioned. Okay, but the main thing I want to speak about today, it's the digitization of the railway network. So why Réseau, why railway infrastructure manager would like to digitize its own network? Well, first, you have you might want to have accurate measurements of your infrastructure. So with like 3D point clouds, you can have precise measurements of precise measurements that you can take directly from the data. So with point clouds, you can make precise measurements like track gauge, alignment, elevation, which are all that critical for ensuring safe and efficient operation of the railway. You might want to have like detailed visualization. So with 3D point clouds, you can they provide a highly detailed and accurate representation of the railway infrastructure. So with this, it allows maintenance teams to visualize the environment, tracks, overhead wires, surrounding structures with large detail without having to go on the place on foot on with sometimes difficulty to access a precise location. You can monitor the condition of the railway over time, comparing data from different time periods. It's with that maintenance team can identify wear, tear, deformation, other issues that need attention. And we have that in mind. It's also it helps saving costs. So reducing unnecessary maintenance activities, focusing efforts on where they are the most needed. And to digitize the railway network, so SNCF Réseau put in place a few trains that are dedicated to that. So they are called ESV, for in French, Engins de surveillance de la voie. And they are equipped with a lot of system underneath that you can see there, but what we are mostly focusing on is the LiDAR parts, which is dedicated to scanning the railway network. So be more precise. So it's to rigor free LiDAR heads that can have like 7,000 points per meter squared, like in a 3 meter range of the LiDAR. So you can have very dense data. So if you make that in perspective with 27,000 kilometers of tracks at like 1,200 billion points per for the entire network, just for this 3 meter range from each side of the track. So it's a lot. It's a lot of raw data that is acquired because these trains they are running on the tracks like 46 weeks per year, 7 days per week. So I let you imagine. And the objective of the circulation of that trains is to cover the network at least twice a year. So there's a lot of challenge because 1 day of acquisition is like 1 terabytes of raw data. And I'll present in the next slide the processing chain that we have. I'm sorry, this one is in French because I didn't have the time to translate it in English, but I'll give you the most I'll make the translation for you. So you have I told the acquisition ways. So the idea is you have the ESG engine surveillance de la voie here, but there are also 2 other vehicles that can scan the network that are. So it's actually 5 trains that can digitalize the network in France. You can bring also over trains in the process, because the factory that we put is able to cope with that. You can have also data that is coming from other sources like airborne LiDAR taken from helicopters. And the first part is to make the acquisition. So that's either railway-borne, airborne, and then transfer all that raw data into the cloud, and then part of the processing is done in a common core automatically, while other parts are done on demand. So you have all that is assembling the raw data, rails extraction, some quality checks, trajectory processing and stuff. And then given the on demand, you can have some processing like gauging, ballast conformity, catenary, geometry. And the result of the various analysis and process, they are afterwards ingested into SNCF Réseau business tools for, experts to use that information. So there's cloud written here because process is done in the cloud, which is an excellent option for processing large volume of data, because the cloud can dynamically adjust resources based on the demand. This means we can scale up during peak times to handle large data loads. So especially when we are transferring data, we have the data is not streamed into the cloud as the trains goes in the tracks. There are sometimes they take the data out of the train, and then it comes here in Altametris. We do the unloading, the transfer to the cloud, and then we have to process. So there are peaks, there are peak times, and the cloud can handle that, scale up, scale down when the demand, scale up when the demand increases, scale down where the demand decreases. So it's ensuring the efficient use of resource. And so we can have that elasticity, but also we can scale well, because the cloud provides like virtually unlimited resourcing. So we can scale the data processing capabilities as we need. So when we have to process a lot of data, the cloud can accommodate that to our requirements without needing to invest upfront in hardware. And we have the flexibility of the cloud. We can use a wide range of tools and services that can be and that are tailored to the data processing needs we have. And this flexibility can help us to implement complex workflows and the integration of various data sources as well. Okay, so we have point clouds. So as I told earlier, 3D data like point clouds allows for a comprehensive analysis of the railway infrastructures. So we can capture detailed information, track geometry, curves, elevation change. So we can assess the overall condition of the railway. So, but there's challenges that cloud can cope with. So data volume, I said 1 terabyte of raw data per acquisition day. So it's raw data. So when it's processed, it's way less, but it's still a lot, as we want to have a lot of information about the tracks. And processing very large and very dense massive point clouds with one of the biggest challenge is data volume, but it's easily coped with data. You have also problem with computational load. So dense point cloud demands high computational power for processing if you want to do some filtering, segmentation, and over analysis. And for algorithm complexity, if you have algorithm that work well on smaller data sets, they may not scale efficiently to handle that massive point clouds. So optimizing the algorithm for performance and scalability is a significant challenge as well. And you have to ensure that the compatibility between different data formats, software tools, it can also be a challenge. So standardization of data formats is also crucial for seamless workflows. And it's also allows more integration. So this data and the format we choose and the way they are stored, you can integrate them in other softwares like QGIS. So typically we choose formats that are well tailored for most softwares and tailored also and for our applications. Okay, so processing very dense and massive point clouds, it involves challenges: data volume, computational load, data management, algorithm complexity. It's quite hard. So it's an illustration we can. So application and processing that we do on that data. We have here a condensed view of 3 applications that we have that I will give some details about afterwards. So you have gauging, you have ballast compliance. So gauging would be part of the blue gauges you can see there. Ballast compliance in green, and overhead catenaries, geometry of that. So that's the main 3 applications that are in production today in our software tools. So it's all beginning with Rails measurements that we have to extract from the point clouds. So that's the beginning of common core processing, and then gauging is done on demand. And the idea of gauging is that if you want to have safety on tracks, you have to detect obstacles, and you have to identify where the infrastructures can be problematic for the circulation of the trains. So the idea is to detect what points are inside the clearance gauges. And then there's also an idea of if we want to detect obstacle, we want to say, okay, here in that example, it's like a platform that's in the gauge, and it's not you have also some vegetation, but the most problematic obstacle here is the platform that's in the gauge, and you want to be able to say there's an obstacle here, but this obstacle here is not a collection of points that you have to determine the nature of, but it's related to some asset and we can identify in some infrastructure database of the maintainers. And typically, we are able to make some clusterization and say this obstacle is the same object. It's not a collection of objects, and we can relate them one to another and say this is a long obstacle, which is a platform, and we can give the ID of that platform in the Réseau modelization of its infrastructure. And so that's for gauging. You have also catenary geometry. I told about. So the idea is that frequent measurements of catenary geometry is vital for maintaining, like, first electrical contact, of course, preventing wear and tear of the catenary itself, and then ensuring safety, complying with all the standards that can exist for the maintainer. You said my catenary needs to be in that position given the geometry of the tracks underneath and stuff. And it also enables predictive maintenance, because if we can compare the geometry of the catenary over time, we can say there's something happening at that right position, and maintenance teams can schedule exactly what they need to do on that precise location. It's interesting to say that before that, measurements were made by specific engines. So there were specific systems that were measuring geometry, and they were running at like 3 kilometers per hour. So I let you imagine how long it would take to measure the entire network, 20,000 kilometers, with like 2 or 3 engines running at 3 kilometers per hour, and being able to insert them into the traffic. So you can do your measurement only by night. You have like 8 hours with no traffic. So you can do like not that much kilometers each year. So with that system, the ESV, they are running at like 80. They can go up to like 100 kilometers per hour. So the capacity of measurement and measuring and having fresh data is really interesting. Third application is ballast filling compliance. So if you want properly maintain the ballast, ensures that the track remains in their correct position, even under the heavy loads exerted by passing trains. So having the right amount of ballast under the track and near the tracks is really vital. And you have to know that it takes about 2 tons of ballast per meter. So when you have operation, when you need to put more ballast, you have to carry that ballast to the right place. And you have also to extract all that matter from like carriers, and so it's really have a big environmental impact, like extracting all the ballast and moving it to from one place to another, and being able to know how many ballast do you have at a given place, and if it is in compliance with the norms. It's really a really good information, because you can also say, oh, there's too much ballast, at that position, we'll remove it, and there's not enough, like 1 kilometer ahead, so we can take what has been removed and put it back on the right place to ensure the 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 filling of the ballast for the tracks. Okay, and so far, this is all that is in production. It started like in 2 years ago, and as of this year, we already processed and stored like 75,000 kilometers of tracks. So it's like 3 times the networks if you remove the high-speed network. So it's really really more that we expected. And we are working on putting more use cases and getting more information from that data. By assessing the vegetation hazard using AI. So we did not spoke about segmentation, AI and stuff on point clouds, because as they are very dense and very large and very specific, it's really it really is a big challenge to come up with an algorithm that gives the results that we want and being able to make the analysis that we need. But by segmenting the point clouds, you can different elements such as tree, shrubs, and other vegetation can be identified and separated from the railway infrastructures. And this allows precise monitoring of vegetation, its growth, encroachment, and it enables the detection also of vegetation that poses a risk to the operations. Trees too close to the track, branches that could interfere with other red lines. So you can assess the hazard more efficiently. And as always, maintenance team can go at the right place at the right moments to make the right operation. And how it can be, it can be, I mean, detection. There are some cases of danger regarding where is the vegetation from the tracks, depending on how the soils is. If you have some like in French is déblai and remblai. So yeah, the risk is higher for the tree that's high up there than a tall tree that would be lower from the track. So you have classes of danger, and we can assess that danger given the position of the trees. But also, you can combine 3D point clouds data with 2D images of railways to enhance object detections and analysis because they are complementary. You can have spatial information about the environments with 3D data, and with 2D images, you have detailed visual information, color, textures, and you can improve accuracy of your 3D information using 2D. You have more context, and there are some objects that can be difficult to detect using only 3Ds, and 2D can help you detect that objects. And then Then you can also combine 2D methods of detection with 3D data. You can like make some specific views of your point clouds to have a representation of the point clouds, like from top, from any perspective you want. So you can make artificial images that can be then processed by 2D by 2D algorithms that are very very good at that, rather than 3D algorithm, AI algorithm that are, I mean, more in development and in the development phase, and on maybe not as robust as that 2D CNN and stuff can do. Okay, and then with all that, you can think of initiating some beam. So initiating building information modeling of the railway network is very challenging, because we are not dealing with a new project, but with existing, diverse, complex infrastructures that's in place, that's been in place for many years, even centuries, and you need to start that on the right foot. And you can do it using information extracting from 3Ds and 2D images, as I presented. So the idea is the process would be to capture detailed spatial data of the railway network using, as I presented, LiDAR, photogrammetry. So you can have with that, it provides precise information about the geometry, the location of all elements. You have the 2D images that can give you high resolution images to have visual details and condition of infrastructure. Then you can determine using several algorithms, AI and stuff, but it's very diverse. Then you can integrate all that data, register, align the 3D point clouds with the 2D images, create a unified data set, ensuring that spatial visual data are all correlated, extract features from both data sets, so say rails, tracks, overhead wires, signals, vegetation. So this involves also a lot of work identifying, classifying different elements within the data, and you can have, as I said, the infrastructure is in place, has been in place for years. So you have a diversity even in one specific signal. You can say there are generations of how it was done, how it's done today, and it's really challenging to say we will build something and we will modelize like 27,000 kilometers of railways. You have to take into account each specificity of each location and each the age of the track and how it is how it has age and all that. And then if when you have all that information, you can start integrating that data all that data can help you create detailed 3D models of the railway infrastructure. So track, bridges, tunnels, all that is relevant to your application. And there might be many objects that are relevant, because for let's say catenaries, you have a lot of stuff related to poor alimentation of trains. So you have a lot of stuff that is dedicated to that specific field. You have signalization, which are also a lot of stuff dedicated to that specific application. Really, there's a lot of expertise that's needed to put into that to be able to make the more comprehensive model from all that data. And then you have to, incorporate that, all the 3D models into the platform, into the BIM model, adding metadata attributes to each elements. And this also is a really challenge. So transforming the geometric model, the vectorization, the digitation that has been done into intelligent objects with the right information. And then, which is not the least, you have to validate the accuracy and the completeness of the model by, let's say, comparing it with the original data, conducting, make field checks, and usually one of the challenges that we have is that it exists some databases on where the assets are and how they are and what kind of asset, but these databases are never perfect. So you have to say, okay, I detected from my point clouds, let's say, all the catenary pools. All the catenary pools exist in some database in SNCF Réseau. And how can we match the information that we extracted with the information in the database? Is the database complete? Is it reliable? And are we able to create that? So that's why I said it's really a question of starting on the right foot, because you cannot, you have to create something not from scratch, because I mean it's working and it's used on a daily basis, but as the way you are modelizing the tracks, the using objects, 3D models and stuff, it means you have to start from something that's robust. If you're building something that's, let's say, have a lot of flows, you can't. I mean, over time, it won't work. So one of the biggest challenge I told is the complexity of the existing infrastructures. So railway networks, they consist of various elements, different materials, condition, ages, and modeling this diversity accurately is very challenging, because you need to put some in place algorithm that will be able to make all that, and building algorithm that can cope with a lot of complexity takes a lot of time to be developed. You also have to imagine that some feature of elements are hidden. So underground cables, buried tracks, you may not be able to access them, just see them. So it's even more complicating to collect all the right data and make the right processing if features are hidden. So you have some cables that are put in some buried and stuff. Then we talked about that when I spoke about clouds, but you have data volume management issue, because you have large data sets, high resolution images. You have a lot of data that's coming out of that. So you have to come up with, it requires a significant storage processing capability. So you have to come up with solutions that can cope with that. And integrating all that information, diverse data types, and maintaining the integrity of all that data throughout all the process is also a complex task, and over time as well. And then given the precision of the level of precision you want from your BIM model, you also have some criticity, because for safety critical information, you want to have a measurement that have a certain a given precision. And so having that kind of precision given the application you want, safety critical or not, you might need to have a demand of even more high quality data, and processing that are even more meticulous. You can say, oh, I need a SEAL4 processing for my data. I need two algorithms that run the same task, and I have to make a cross validation between both and stuff. So deciding also the appropriate level of details for different parts of the model is also essential to have that balance between accuracy and manageability of the process of the workflow, and what can be done with that, what kind of data. And then yeah, it's also it might be very time and resources consuming, because yeah, creating that model, having the right human resources, specialized skilled personnel to put that in place, because you can have people that do the software, but you need to have experts that say, for my business, for my area of expertise, I need to have that kind of information. You have to align people that say, okay, with software, with algorithm, I can do that. For your specific area of expertise, you need that kind of information on how we can make that work together. So yeah, starting on the right foot, it's mean having the right planning, having a really strong strategy, having also a lot of involvement from stakeholder, because yeah, having operators, maintenance team, regulatory bodies to ensure that the model meets the needs and the application. Yeah, that all that, and having also an efficient workflow, because you can say, okay, we'll start BIM modelization of the tracks, and say, okay, but what are the costs of all that? What are what is also the approach to be able to modelize that, to come up with something that will not cost like millions of, or for the establishing the first like model of the entire network. So yeah, establishing the standardized processes, modeling the streamlined workflow, reducing errors. It's also very, very important to have something that we can rely on. And usually in railway infrastructure, railway management, security, reducing error is really a big a very big deal, because you have always the safety first. So being able to come up with new methods, new modelization, needs to ensure the same level of safety that the previous method was using. So adopting some iterative approach, it's also for continuous improvement, refinement, based feedback also from the teams that uses the new methods. And yeah, there's a lot of new technology and new softwares that supports integration of 3D, 2D to allow that also. So you have to leverage all that new improvement on that specific topic. Yeah, automation, machine learning, all that helps enhancing the data processing, feature extraction, so you can build efficiently and with accuracy your big modeling. So yeah, that would be the conclusion of my presentation. You can do a lot of stuff with algorithm extracting information, and that's really great. And then you have to address the challenges of the complexity, the data management, the accuracy, strategy, planning, data collection in high quality, to have the workflow that are efficient and the right technology to ensure that all that is working, and starting on the right foot with that in mind is very crucial to ensure the success and the sustainability of that beam initiative of the railway network, I would say. So that's all for me. Thank you, and I think it's now time for the question. I give you back the floor, Jeremy.
Yeah, thank you very much, Guillaume, for a very nice presentation. So yes, we have some time for some questions. So if you have any question, please you can